Well, hi everyone. I've done a number of stories about the Washington Bridge closure in Rhode Island, the sudden emergency closure that occurred on December 11th, 2023, and the news just keeps coming and coming on this whole episode with this bridge. And the people of Providence and East Providence continued to deal with the huge impacts that the closure of the westbound lanes has presented in terms of extended commute times and just general chaos. So there's a variety of engineering studies going on right now. After the bridge was closed, Rhode Island DOT Director Peter Alviti indicated that he expected the bridge to be closed for a period of 3 months so that repairs could be made to the westbound bridge lanes to reopen them to traffic. As we know, instead, they continued to inspect the bridge and found more and more extensive deterioration, damage, and distress throughout the bridge structure. So an independent review was done by VN Engineers, and their report was expected here around late February. The draft report leaked somehow to the Boston Globe, who published it on X, and I've been able to review that report. We're going to go through it here in this video. So unfortunately, the news is not good relative to the time frame of restoring the traffic capacity to this bridge. It's interesting to me that they even produce this report as a draft on reports that I stamp, which will be similar fashion stamped by the engineer associated with this study here by VN Engineers. I just issue the report. I don't submit a draft and see what the client thinks and then massage the report to try and keep people happy. I'm not saying that's what's happening here. I just think it's a bit unusual that a draft is circulating of this report. It didn't indicate that more information is pending. So to me, the only difference between a draft and final report would be the degree of recommendations and how pointed they would be in the report. And essentially, the news media has accurately reported that this draft report doesn't contain any clear-cut recommendations as to whether the bridge should be repaired or replaced. But in engineering terms, it very much tells you what needs to be done here. So we're going to go through that in this video. So let's go through some of the key findings here. So as you recall, on December 11th, this bridge was closed because on the prior Friday, 3 days before, what's been termed a junior engineer associated with rehab work on the eastbound bridge lanes noticed excessive deflection of the westbound bridge deck near piers 6 and 7. And upon further examination, he saw that the anchor rods had sheared off completely, which was quite alarming. So there was a series of communication. Rhode Island DOT closed the bridge on Monday afternoon. So they've had 2.5 months to conduct further inspections, destructive and non-destructive testing, just to get a better handle on whether this bridge can be rehabilitated and put back into service within a shorter time frame than a replacement would take. So I want to read from the executive summary. The I-195 westbound Washington Bridge is a complex structure composed of 18 spans of various structural types, including post-tension PT cantilever beams, drop-in pre-stressed girder beams, simply supported steel beams, and simply supported pre-stressed girder spans. The bridge is inherently non-redundant in global configuration due to the balanced and unbalanced nature of the bridge. The cantilever beams themselves do not have internal PT redundancy or adequate access to allow for the inspection, maintenance, or replacement of the PT elements. So in plain language, this bridge was designed in a really complicated fashion, made it hard to inspect. There were key structural elements that if they failed, there was no backup with other elements that could take the load. That's what they mean by non-redundant. So if something fails, it could lead to the complete collapse of the bridge. We saw this with the Fern Hollow Bridge that had extensive corrosion of the support legs. There were 4 support legs for that bridge. And the corrosion was clear through the main structural support, which again was non-redundant. And then over time, the deterioration resulted in the bridge not being able to carry its design load, and it collapsed as traffic, including a double bus, which was segmented, triggered the collapse, and it appears from that video. So anyway, I did a video on that. You could check it out here. But In this case, the extent of the deterioration and damage for the Washington Bridge is quite shocking. So they say this report constitutes the assessment of the PT systems for the Type D cantilever beams located at Piers 6 and 7, which is the locations where they saw the broken anchor rods. And some of these rods are exposed, many others are not visible and cannot be visible unless they tear the bridge deck apart. Additional inspection and field testing along with the remainder of the bridge is ongoing. However, currently available documentation is provided within this report. So maybe there is additional information. I think they've got plenty to make a decision at this point, but we'll get to that. The field inspections and field testing performed on the structure to date have documented the following deficiencies: failure of multiple tie-down rods at Piers 6 and 7, exposed PT anchorage assemblies undergoing active corrosion. We saw from those pictures that there was extensive corrosion of those tie rods. Significant voids within the PT ducts. So if you have a post-tension steel member, it has to go through channels or pre-made holes in the bridge structure. And some of these are grouted in place and some are not. But they're talking about extensive corrosion. And then to the extent that there was grouted zones, there looks like there's deterioration of that grout. So when there's deterioration of the grout, then there's not efficient load transfer from the post-tension member to the rest of the structure. So it's not locked in like it needs to be in terms of load transfer. Corrosion of PT tendons within the PT ducts, unsound concrete in the anchorage development zone of the concrete beams, web cracking along the PT ducts at beams throughout the structure. The concrete at beams at Piers 6 and 7 are vulnerable to freeze-thaw damage. That's because this bridge was built from 1967 to 1969 when it was opened, and they did not use air entrainment in the concrete as they commonly do now. So concrete that doesn't contain air entrainment is much more susceptible to damage from freeze-thaw action. It basically causes spalling and deterioration of the concrete over time. You may have seen this on driveways or patios in cold climates where it just kind of chips away by itself. That's freeze-thaw action. And then deck joints leaking above PT anchorage assembly throughout the bridge. So again, these assemblies aren't visible in many parts of the bridge, but yet they're exposed to water and they know they're deteriorating. In fact, it's not just plain water, it's salt water. When the snow and ice melts in the winter and they salt these bridge decks to keep ice from forming. And this salty water is extremely corrosive to steel elements in bridges like this. So here they talk about the capacity for the bridge to carry the design loading is just not there because of this deterioration. It says here, repairs and strengthening of the bridge would be a complex operation that carries the risk with regards to viability and sufficiency to fully address the deficiencies within the system. The ability to thoroughly identify and access all areas of the PT systems that require repair carries risk. This is due to the inaccessibility of locations on the structure and the geometry of the PT beams themselves. The viability of repair requires the removal and replacement of the existing deck to lower locked-in load within the PT beams. Removing the existing deck carries risk due to the significant load redistribution that has occurred within the loss of the tie-downs at Piers 6 and 7. The ability to reuse the existing beams for anchoring of external strengthening is a risk due to the unsound concrete present at the beam ends. The repair and strengthening options for the Washington Bridge are limited, complex, and do not completely mitigate the identified risks with the structure. Now let's go on here. They do a demonstration of how post-tensioning works for a concrete beam. First they show a simple beam that's not reinforced, which is prone to tension cracking on the opposite side of the member that's being loaded. And then you have normal reinforcement where cracks can still occur. And then you have a post-tension beam that carries the load without the development of such cracks. So in other words, you rupture those reinforcing elements and the concrete's likely to crack, which is what's happened at numerous locations in this bridge. I mean, we just see example after example of poor condition. I mean, this bridge was documented to be in poor condition for several years, including its most recent inspection in July of 2023. You see longitudinal cracking in the web of the beam for Pier 6. Look at all these cracks here. It says, inspection photo of distress found at end of beam A near Pier 6. That kind of cracking is very problematic. So let's go to the conclusions in the report, such as they are. So here they go through the review of repair and strengthening options. I don't want to go through this in a lot of detail. Let's go through the bottom line. To thoroughly repair and strengthen the Washington Bridge would require a combination of the above or similar repair and strengthening concepts. None of the repair and strengthening schemes noted, however, addresses water infiltration at deck joint locations. Water infiltration at these locations directly over the PT anchorage assemblies would remain a long-term risk for the structure. The repair and strengthening concepts do not eliminate the tie-down detailing at the west abutment, Pier 6 and Pier 7 locations. The schemes do not improve the inspection, maintenance, and repair access along the structure, but further complicate it. Additionally, these schemes do not allow for the inspection, maintenance, and repair access to the west abutment tie-downs or beam ends with their post-tension anchorage systems, which are currently inaccessible. To fully eliminate these risks and improve inspection, maintenance, and repair access would require a full superstructure replacement and potentially a full bridge replacement. The reuse of the substructure for a superstructure replacement would need to be further investigated to confirm the feasibility and viability of the substructure for reuse. Initial investigations into the feasibility of the substructure for reuse from a condition and strength perspective are ongoing and being performed by others. So one of the things they mentioned in the report is if they try and repair this bridge, and I perhaps should go through this real quick in terms of what the options were for repair. So you close the joints along the length of the bridge to prevent water infiltration. You repair the post-tensioning system and beams. You strengthen the existing beams using external post-tensioning systems. And then you strengthen existing beams using fiber-reinforced polymer. You can put another beam next to the one that has distress, and there's other methods you could look at. So let's look at a couple things here. In a nutshell, what this report indicates is that trying to repair this bridge would not only be dangerous, it'd be kind of a nightmare because it's like working on an old house. I don't know if you've had this experience, but I had a house that was over 50 years old, and I'd go to, say, fix a plumbing related problem, and there would be 2 or 3 other things that I would discover in the course of that repair that also had to be fixed. And that's what's going to happen here if they decide to go with a repair option. I don't see it happening. The bridge is at the end of its normal design life at 55 years at this point. The engineer in this report points out that this was a very complicated design. It wasn't a very good design from the standpoint of maintenance and inspection. And if you're responsible for managing the transportation infrastructure for projects in Rhode Island, you need some degree of certainty. You can't tell people, okay, it's going to take us 12 months to repair the bridge, and then you get into it and realize, oh, no, it's not repairable, or we found many other things that now have to be fixed. So instead of 12 months, it's going to be 24 or 36 months. So they'd be better off just simply replacing the bridge. Now, that's going to be a major undertaking. And as I pointed out in previous videos, there's permitting aspects. I don't think a design has been performed for a westbound bridge replacement. So the most expedient thing, even though it could take a long time, I think in my previous video, I thought that they could accelerate bridge replacement and it would take somewhere between 18 to 24 months. And many of you commented, there's no way, this is going to take much longer. And seeing how slowly they've moved on this so far, I completely agree. I think the bridge is going to have to be replaced. There's no question about it. I don't know why they're dragging their feet, trying to get more data or trying to get the nerve to just tell people that their impacts are going to be ongoing for a much longer period of time. So Alviti admitted a few weeks ago that the bridge may need to be replaced altogether, and that was before this draft engineering report was leaked to the media. As I mentioned, this bridge was noted to be in poor condition, that is structurally deficient, for several years, including its most recent inspection in July of 2023. Now, I noticed in this engineering report, they didn't get into the timeline of the failure of the components that they noted in their report. And they didn't get into whether there were any deficiencies in previous inspections that might have missed some of these serious problems with the bridge. But if you read between the lines in their report, they basically say this bridge is extremely hard to inspect and know exactly what's going on with it, given the way it was designed and built. Now, there have been recent media reports about specks of blue paint on the broken portion of these anchor rods. So if you can pin down when the painting occurred, you would know that the damage occurred prior to that painting event. But no further information has been presented about that. Now, we talked about some of the impacts the closure of these westbound lanes has had. You see a huge drop in business in East Providence. Some people are talking about moving. It's just too big of an impact on their lives or businesses. You've got the whole political aspect of this thing, where apparently this problem with the bridge was noted on a Friday, December 8th, and it wasn't until the afternoon of Monday, December 11th, that the Rhode Island DOT director was made aware of what was going on. And then about an hour after that, the governor of Rhode Island was notified. So the governor appointed one of his staffer to be involved with all aspects of this bridge evaluation going forward. So that signals, I think, a loss of confidence perhaps in Director Alvidi's ability to manage the situation. And the contractor who lost out on the repair contract for the eastbound lanes pointed out that these joints could fail, and no action was taken to further investigate his claims, apparently. So the other dynamic you have with this whole project is what's going on at the top of Rhode Island DOT. And I've been critical of Director Alvidi from the standpoint of him throwing information out there that wasn't based on any apparent evidence, such that there must have been a rogue truck that crossed and caused this damage to the bridge subsequent to the July 2023 inspection. And if it weren't for that junior engineer, that damage wouldn't have been known. You know, now they're obviously not talking about a rogue truck that was overloaded, because the damage and deterioration of this bridge is widespread. Another knock on Alvidi, one of the early press conferences he had after the bridge closure, is he floats this picture to try and prove that, you know, this anchor wasn't broken in the July inspection. So he's comparing the July inspection photo with the December photo when the damage was noted. But the problem is the angles are different. So the location in question isn't visible in the July 2023 photo. So I thought that was highly misleading. You know, as I mentioned, Alvidi said the closure would be for 3 months while they get repairs done. We're 2.5 months in, and they're still trying to decide what to even do. And as a perhaps sign of things to come, they've decided to add 2 new lanes, one in each direction, by tightening the width of the existing lanes so they can get more traffic onto the bridge, although the traffic's going to be limited to a speed limit of 40 miles per hour. So I think the delays and congestion are just going to continue. And I think a number of people in Rhode Island have lost confidence in Director Alvidi. There's a change.org petition for his resignation. So again, I see no way that this bridge is going to be repaired and put back into service. It's going to take a complete replacement. In that engineering report, they mentioned that somebody else is evaluating whether the substructures could be reused. That is the pier and the foundation that's supporting the superstructure of the bridge. I can tell you in my business, I've been involved with testing foundations on hundreds of bridge projects during construction, and they were all new foundations. I can't think of a single instance where a foundation was reused. Because if you try and reuse the foundation, you have to have the spans at the same location again. You know, the condition of the piers is largely unknown as well. It just seems foolish that anybody would even consider trying to reuse these piers in the foundation. I can understand why, because presumably you could save a lot of time by not having to rebuild those. But again, based on my experience and just the ongoing uncertainty with the condition of this bridge relative to its age, everything's got to go. So then it's a question of, do environmental studies need to be done? Can the money be gathered to do this bridge replacement? I have no doubt about that. You know, I floated an idea that this replacement would cost around $200 million. And some of you said that was on the low side. And I think you're probably right. Just given how things are going out there, this is easily a $300 million project at this point. I mean, they spent $2 million alone since the closure doing additional studies and trying to mitigate the impacts to the traffic. So to me, it's very interesting how these engineering related stories play out. You have engineers in front of cameras, engineers behind the scenes, and then you have the general public that's trying to make sense out of things. And that's what I'm trying to help out here with these videos. And there needs to be, I think, stronger leadership with the state of Rhode Island and in particular their DOT. You know, if I saw a fraction of what was in this report, in my mind, there'd be no question that this thing had to be replaced. So to continue dragging things out, to get more information, to deliberate, to maybe get preliminary cost estimates from some contractors to implement these repairs is a complete waste of time. They've just got to cut their losses and replace the bridge, in my opinion. I think that's where this is headed. So let me know what you think. I'd like to give a shout out to the channel members. I have a 1-tier membership. Some of the benefits are they get to preview my videos before they're released broadly. Also, it supports the channel and enables me to continue posting videos at least once a week. Also, I want to send a shout out to those who have provided super thanks. That's another way to support the channel. And those of you who have liked and subscribed and commented to my videos. If you'd like to check out my free digital download of the top civil engineering disasters of the past 100 years, there's a link in the description. Thanks very much, everyone.